Hello and welcome to the Writing Polynomial Equations from a Graph video. The first problem and the last problem are going to be a little bit review, but in the middle we'll cover looking at a graph and writing the equations. So for this first problem of the review, we're going to take a look at problem number 4 here, this graph. Part A says determine whether the polynomial is even or odd. And we're going to take a look at that by looking at where the ends are. And I see that both of these ends here are pointing upward. So I'm going to redraw that table that we've been using. This is also going to help me with the part A and B, where we take a look at our leading coefficient, whether it's positive or negative. We take a look at our degree to see if it's even or odd. If we have a even degree, so like a 2 and a positive leading coefficient, both of the ends are going upward. If we have an even degree and a negative leading coefficient, it gets reflected and moves downward. If we have an odd degree, so like a line or an x cubed, and a positive leading coefficient, the right side is up and the left side is down. And then if we have an odd degree and a negative leading coefficient, that gets reflected. So we'll take a look at this for our first few problems. So for problem number 4, I see that both my ends are going upward, just like this. So we know we're going to have an even degree. And then for part B, we can say that our leading coefficient is going to be positive. So that's the sign right there. I actually write out the word positive, but if you just gave me a plus sign, that's also okay. Part C asks for the number of turning points. And this is where we're changing, going from up to down. Now, if we kind of zoom in a little bit, we have this kind of flat piece right here. So it's like, is that a turning point? Do we know? This is actually like 2 very, very tiny turning points. So you can think of it as like one like right here and one like right here. We just kind of did like a really small little divot like this. And we'll see a slightly more obvious one right here. So for our number of turning points, we actually have 3 turning points. Let's write number of turns is going to be 3, which means that our degree, which is always 1 more than our turning points, this is going to be a degree 4 polynomial. And this tracks because we already knew it was supposed to be even, and 4 is an even number. So I just wanted to point out kind of this piece right here, but feel free to work on some of those others in the Go formative. But now that we've gone over that material, mostly from the first day of this unit, I want to take some time looking at some graphs and writing some equations. So I'm going to zoom in and scroll down. I don't know why there's so much space there. Here we're going to have 9 graphs. We're only going to go over 3 of these. We can see these are all different polynomials, and for each of these, a point is specifically designated. So here it's, actually, let's just take a look at that first one there. Here it's -3, -12. So we're going to be using this point to help us find our function. First thing we're going to do is we're going to want to look at all of our different x-intercepts. And what does that look like? Or let's call them roots. So I'm going to move this over just so we can see that in the screen. We see them here and here and here. So if I wanted to talk about what's happening, well, the first one, we have x is equal to -4, and it looks like it's going straight through the graph. So I'm going to say that that is a multiplicity of 1. It's going straight through. Next, I see one at 0. So a root of x is equal to 0, and this is also going straight through with a multiplicity of 1. And then my last 0, or my last root I have right here, on x is equal to 1, and that is also just going straight through. So x is equal to 1, again with the multiplicity of 1. So remember, multiplicity means what does it look like, or what's the behavior around the root? If it's going straight forward, or straight through, it's a multiplicity of 1. We'll talk about other multiplicities in the next problem. But now that I have this information, I'm going to try to create as much of the function as I can. So we're going to have f of x is equal to some multiplier out in front. I don't know what. I'm going to call that a. This could be a negative number, it could be a positive number, it could be a fraction. We don't really know. So we're going to just put an a out in front. And then we're going to write all of our different factors. So if we have x is equal to negative 4 as a root, as a factor, that's going to be x plus 4. And this has a multiplicity of 1. So if you want to write a 1 up there, you can, but you certainly don't have to. Our other factors are going to look like x, or x plus 0, if you'd like, as well as x minus 1. And again, if you'd like to put multiplicities of 1 up there, you can. But this is as much of the function as we currently have. We have all of our factors here with their multiplicities, but I need to know what that a is. So in order to figure that out, I'm going to be using this point right here, my negative 3, negative 12. So I'm going to plug in negative 12 for this y value, and I'm going to plug in a negative 3 everywhere I see an x. There we go. So I'm plugging in a negative 3 everywhere I see an x. So I'm plugging in this point because we know this x value and this y value, and now we want to solve for a by simplifying. So we're going to have negative 12 is equal to a times, let's see, negative 3 plus 4 is 1, times a negative 3, times negative 4. So let's see, 1 times negative 3 times negative 4 is going to give us a positive 12. So we have negative 12 is equal to 12a, and then if I divide both sides by 12, I end up that a is equal to, negative 1. So that multiplier we have out in front is a negative 1. And this actually makes sense, because if we look at what directions our ends are going, this is an odd degree polynomial, and we say, hey, left side's up, right side down, the number out in front should be negative. So we're not completely done yet. We've got one last step. We're going to write our final official equation. It's going to be f of x is equal to negative 1 times x plus 4 times x minus 1. That's our official equation or function for problem 1. Now, if you just wrote this as a negative as opposed to negative 1, that's okay. If you had your factors in different orders, that's okay, as long as you have all this information in there. So let's try one more. Let's take a look at the fourth problem here, the one just right below it. Oops. So if we take a look here, this one, far more interesting. Look at this graph. Look at all the different things that are going on. So let's see. I see we have a root here, a root here, a root here. Now, the one here at 3 is going straight through, but the one here at negative 2 is bouncing off kind of like a quadratic. So for this problem right here, when we list our roots, I'm going to say this is at x is equal to negative 2 with a multiplicity of 2, because it looks like a quadratic. For my next one, I see that we have a root at x is equal to 1, and this one, it goes through the other end, but like kind of has this like wiggle wobble to it, or it kind of looks like a cubic function. So we're going to say that this is a multiplicity of 3, and then lastly, we have a root when x is equal to 3, and this goes straight through. So we're going to say that is a multiplicity of 1. So when we write out our full function, we'll have f of x is equal to some a value we have to find out, and we'll have a factor at x plus 2 with the multiplicity of 2. Don't forget that multiplicity. We'll have a factor of x minus 1 with the multiplicity of 3, and then we'll have a factor of x minus 3. If you want to put the multiplicity of 1 in, you can. You certainly don't have to. Now, when I get to this point, I'm like, I don't know what a is. So we're going to use this point of 2, negative 15 to plug in and solve. So we're going to have negative 15 as our y value is equal to an a value we don't know times 2 times 2 squared, whoops, times 2 minus 1, cubed, got a little ahead of myself, times 2 minus 3. So I'm plugging in a 2 everywhere I see an x. I'm plugging in negative 15 for my y. And now I'm going to solve. let's see, we got negative 15 is equal to a times 4 squared times 1 cubed times a negative 1. Let's see, a times 4 squared is 16. 1 cubed is 1 times negative 1. So 16 times 1 times negative 1, that's going to give me a negative 16. So you have negative 15 is equal to negative 16a. So from here, I'm going to divide both sides by a negative 16. And we end up with a positive 15 over 16 is equal to a. You can plug this into your calculator if you want and get a decimal. Third decimal place, please. But that seems like a lot of work. This was, I think, kind of quicker. So we've found our a value. We're not done yet. We have to take it and plug it back into our equation. So f of x is equal to 15 over 16 times x plus 2 squared times x minus 1 cubed times x minus 3. And this is your equation. If you had your factors in a different order, that's okay, as long as they still had the correct multiplicity. If you switched the factors of x minus 1 and x minus 3, but left the multiplicity of 3 in the middle, that's not okay. So if you're switching your factors, that's fine, as long as the multiplicities come with them. So hopefully you're getting the hang of this by now. Let's just try one more. Make things a little more fun. Sometimes we get some big numbers, and I kind of want to show you what happens there. So if we move over to problem number 8, let's see, do I have enough room here? Maybe. We'll make it work. So we're going to take a look at problem number 8 right here. Take a look at all of our factors. So this one's similar to the one that we did previously. We have kind of that weird like flat line right there. That's a cube, so or a multiplicity of 3. Oh, something I also forgot to say. I'm going to move back to the previous question very quickly. Again, we know this is correct, 15 over 16, because both my ends are facing upward, meaning that we have a positive leading coefficient, which is what we end up with. So always use that to double check. So if we're taking a look at number 8, again, both of the ends are facing upward, meaning a positive leading coefficient. I know my answer should be positive. If I go through my work and I get a negative number at the end, I know I should go back and check it. Let's write down what we know. Let's just zoom in a whole bunch. Okay, I might have to scrunch my work a little bit. So let's see, we're going to have x is equal to negative 2, and it goes straight through, so that's a multiplicity of 1. We have x is equal to 1, and this is a multiplicity of 3. We also have x is equal to 3, and this bounces off like a quadratic. So that's a multiplicity of 2. Now when we go through and write our equation, we'll have f of x is equal to some a value, we don't know what yet, times x plus 2. You can write a multiplicity of 1, you don't have to, times x minus 1 with a multiplicity of 3, times x minus 3 with a multiplicity of 2. So very similar to the previous problem we had, just different multiplicities. How does this change things? Well, again, we're going to look at our given point, plug in what we can. So we're going to plug in negative 125, kind of a big number, equal in my y value, and I'm going to plug in negative 1 everywhere I see an x. So I plugged in my y value, plugged in my x values. Let's go through and solve. So we're going to have negative 125 is equal to a times negative 1 plus 2 is 1. Negative 1 minus 1 is negative 2. We're going to cube that. Negative 1 minus 3 is negative 4 squared. So now I'm going to apply all the multiplicities. Please do not forget those. So it's going to be a times 1 times negative 2 cubed is a negative 8. Negative 4 squared is a positive 16. So we have 1 times negative 8 times 16. That's not something I know off the top of my head, so I'm going to grab my calculator. And I get that negative 125 is equal to negative 128 times a. So I'm going to divide both sides by negative 128. This is kind of a big number. Again, you can plug this in your calculator if you want. I'm just going to leave it as a fraction. Negative divided by negative is a positive, so this is positive 125 over 128 is equal to A. Now, if you're dividing by a decimal, you're going to end up with a decimal as your answer, and that's okay. But we found our A value. So let's go through, rewrite our function. F of x is equal to 125 over 128, which is positive, so we know we've done this correctly, times x plus 2, times x minus 1 cubed, times x minus 3 squared. And that's the answer to that 8th graph right there. So this is kind of the main portion of the video. I am going to go over one more problem. Thank you for sticking around. So this last problem is looking over more what we did yesterday and drawing a graph. So how are we going to draw a graph? There's going to be 4 of them there. We're only going to do 1 of them. The instructions here say, use your knowledge of end behavior, roots, and multiplicities, which we've already been practicing, and sketch a graph of the polynomial function. So, you know, we may not necessarily, well, we can see for problem number 11, we can see the A value is 1, but I'm not going to have you make a table or anything. We're just going to look at the behavior. So if we take a look here and we look specifically at those roots and multiplicities, I'm going to do what we did, what we have been doing, but backwards. Instead of looking at the root and writing the factor, we're looking at the factors, writing the root. So at x plus 3, that's a root at x is equal to 3. There's no multiplicity here, which means it's going to go straight through. So let's see, that's going to, pardon me, negative 3. That's going to be right there on the graph. Our second factor, x plus 1 squared, that's x is equal to negative 1. And that has a multiplicity of 2, so we know that should bounce off at some point. So it's going to be there. We have x by itself, which means x is equal to 0, and there's no multiplicity, so it's going to go straight through the multiplicity of 1. And x minus 2 as a factor means x is equal to a positive 2, and that's a multiplicity of 1. So we have all of those points that we need. We know their behavior. Lastly, it asks for the end behavior. Well, I take a look at this. We have multiplicity of 1 plus 2 plus 1 plus 1. It's 1, 2, 3, 4, 5. So this is an odd degree. And like I said, I don't see anything out here, so I'm going to assume that's a 1. And that's going to be positive. So it's an odd degree with a positive leading coefficient. You can redraw the table if you want, or box if you want, but it's my assumption. Right side's going to go up, left side's going to go down. I'm using these arrows more as just guides. I don't necessarily have to reconnect to them, but I know this is the general outline. So now I'm going to get started and make sure I'm following through to the best of my ability. So I'm going to start down here. I'll start with this arrow. I know I have to go straight through. Oops, that was not very even. I know I have to go straight through this root. It's got to come around at some point and bounce off here. So again, we know we're supposed to have a multiplicity of 2, so we have to bounce off here. And then we have to come back around somewhere really tiny and go straight through this root, turn around somewhere else, come straight through this root. Oh, and I was able to reconnect mine. So if your, maximums and minimums are like lower or higher or something, that's okay, because I'm not looking particularly at those. I'm looking to see what does it look like around these roots. 1, 2, 3 of them should be going straight through, and my root at x is equal to negative 1 should be bouncing. So this was kind of a quick way to do a graph. This is the last of the new material for this unit, so please let me know if you have any questions, and I look forward to seeing you in class.